Okay, these are the additional practice problems for Chapter 11 of Chemistry. So in number 1, there are some chemical reactions that you are asked to identify the acid and the base. So we'll write those out first. Okay, so in identifying the acid and the base, you're just looking to see who is donating the hydrogen ions and who is accepting them. So if we look at this and this, it went from 5 hydrogens to 6, so that accepted the hydrogen ions, so that is the base. And then if we look at this, it went from a H6 to H5, so that donated the hydrogen ion, so that is the acid. And then the second one for number 1 is this. Okay, so again, looking to see what happens to the hydrogen ions. So this went from 2 hydrogens to 1 hydrogen. Okay, so it donated its hydrogen, so that makes this the acid. And this went from 18 hydrogens to 19 hydrogens. It accepted the hydrogens, and so that makes that the base. Okay, number 2 says that HI is a strong acid. It's a strong enough acid that it will make water act as a base. What is the chemical reaction between them? Okay, so if this is the acid, it's going to donate the hydrogen. This is the acid, it's going to donate its hydrogen ion to the water, and you're going to end up with a hydronium ion. And the only thing you have left over is the iodine, or the iodine. And then we have to balance it. So 3 hydrogens there. Oh no, okay, I guess it is balanced. So we have 3 hydrogens, 1 oxygen, 1 oxygen, 1 iodine, 1 iodine. Okay, so that is already balanced. Okay, then number 3 is a series of chemical reactions. We're asked to write the reaction. So A is HCl and NH3. Okay, so right away you should recognize that NH3 is the base and the HCl is the acid. So the hydrogen will be given to this to have NH4. And then you will have the chlorine left over. And then, let's see, there's 4, so that's balanced. Okay, then number 2, or number 3b is H2CrO4, and it's going to react with aluminum hydroxide. Okay, so this tells you that's the base, this tells you this is the acid. So the hydrogens are going to come over here and react with the hydroxide ions to give us water. And then you're going to end up with a salt. So you'll have the aluminum chromate left over. 0.4 is chromate. Unfortunately, I don't think the chromate is on your list of polyatomic ions. So I guess I need to tell you that it has a charge of 2. So the aluminum has a charge of 3. And this has a charge of -2. Okay, so we're going to have to switch those charges. So the 2 comes over to be with the aluminum. So aluminum is 2 and the chromate is 3. Again, that's one that is not on your list, so wouldn't expect you to know that, and it won't be on the test, but so that you can see how this is done. So now we balance it. So the aluminum, we'll put a 2 there to take care of the aluminums. And then we have 2 plus 6, we have 8 hydrogens over here. Aluminums are okay, the chromine, so we have 3 of the chromine, so we'll just put a 3 here. So now we have 6 plus 6, we have 12 hydrogens, so let's fix that by putting this there. Okay, so that is the reaction that you would get for question 3b. Okay, and then 3c is between H3PO4 and NaOH, sodium hydroxide. Okay, so again, that hydroxide tells you that's the base, this tells you that's the acid. And so these hydrogens come over here, react with that to give us water. And then we have NaPO4. Okay, so the charge on sodium is +1. The charge on the PO4 is -3. So we'll switch those charges so the 3 comes over there with the sodium. Okay, now that when we balance it, so we'll put a 3 here to balance the sodium. Now we have 6 hydrogens. So if we put a 3 here, that balances the hydrogens. PO4s are okay. If we look at the oxygens, we have 3 oxygens and we have 3 oxygens. Okay, so that is that reaction. Okay, the number 4 and number 5 are both neutralizing reaction. And we are told that we're going to mix hydrochloric acid and calcium hydroxide. Okay, so they'll always start by writing out the chemical reaction. Okay, so here's our acid, here's our base. The hydrogens from the hydrochloric acid are going to come over here with the hydroxide and form water. And then you have calcium chloride as your salt. And we look at the charges. The charge on calcium is a +2. charge on chlorine is -1, switch the charges, so that 2 is going to be with the chlorine, so it's going to be CaCl2. Okay, now let's balance it. Put a 2 there. Now we have 4 hydrogens over here. We only have 2 over here. So let's put a 2 there. I think that's probably it then, and it's balanced. Okay, so now the information that we are given is that we have a 0.75 molar solution of this, and that's all we're told about that. Then we have 250 milliliters of this, 250.0 milliliters of this, and it is a 0.010 molar. Okay, so again, we're told information about one thing, asked to find something else, so we have to get, we have to do stoichiometry, and that requires us to get to moles. So molarity times liters is equal to moles. Okay, so all I did with there was just, you know that molarity is moles over liters. So I just rearranged this equation to solve for moles, multiply both sides by liters. Okay, so the molarity is 0.010, and molarity means moles per liter. And then we'll multiply by liters. And so that 250 milliliters needs to be converted to liters. Just move the decimal place 3 places to the left. Okay, so liters are going to cancel, and you will be left with 0.25 moles. No, that can't be right. It's 2.5 times 10 to the negative 3 moles. So you have two significant figures. So it's going to be 2.5 times 10 to the negative 3 moles of calcium hydroxide. Okay, so hang on to that. We'll erase some of this. Okay, now that we know the number of moles of the calcium hydroxide, we can use stoichiometry to determine the moles of HCl. So 2.5 times 10 to the negative 3 moles of calcium hydroxide, and there are 2 HCl's for every 1 calcium hydroxide. Okay, so you're going to take 2.5 times 10 to the negative 3 and divide by 2. And so that will give you check my math here. So 0.2500 times 0.010, yeah, 2.5 times 10 to the negative 3, and times 2. It's going to be 5.0 times 10 to the negative 3. Okay, so 5.0 times 10 to the negative 3 moles of HCl. Okay, so let's see it. The calcium hydroxides will cancel. So 2.5 times 10 to the negative 3 times 2 is 5.0 times 10 to the negative 3. Okay, and we're not quite there because we were asked what volume of that is required. So now we know that it's 5.0 times 10 to the negative 3 moles. Okay, so we have everything that we need now to determine the number of liters. So again, taking that molarity equals moles divided by liters. Solve for liters, so multiply both sides by liters. So this is just algebra. And then divide both sides by molarity. So it gets rid of there. So liters is equal to moles divided by molarity. Okay, so now we'll put numbers in there. Liters, the number of moles was 5.0 times 10 to the negative 3 moles. And the molarity was 0.75 molar, which is the same as moles over liters. And so moles are going to cancel, and you will be left with 6 with two significant figures, it's going to be 6.7 times 10 to the negative 3 liters. And if you want to multiply that times 1,000, it will give you 6.7 milliliters. Okay, so a concentration of hydrochloric acid at 0.75 molar. If you have 6.7 milliliters of that solution and add it to the 250 milliliters of calcium hydroxide, you will end up with a neutral solution. But our answer then is you would need 6.7 milliliters of the hydrochloric acid solution. Okay, then the last one, number 5. A student needs to neutralize 550 milliliters of a 5.6 molar H2SO4 solution. How many grams of aluminum hydroxide should be used? Okay, so again, we start by writing the chemical reaction. So it's a reaction between H2SO4 and aluminum hydroxide. That's going to form water. And aluminum sulfate. Okay, so the charge on aluminum is +3. The charge on SO4 is -2. So we switch those charges, so it'll be Al2 and the 3 comes over there with the sulfate. Okay, now we balance it. So let's put a 2 here to balance the aluminums. We have 3 SO4s there, so let's put a 3 here to balance those. And now let's look at the hydrogens. We have 6 plus 6, so let's put a, oh, is that right? Yeah, so we have 12. So 6 plus 6 is 12, so let's put a 6 there. And then the oxygens, we have 12 plus 6 is 18. And we have 6 plus 12 is 18 over there. So that's the balanced equation. So here's what we have. We have 550.0 milliliters of H2SO4, and it's 5.6 molar. Okay, so let's get moles of that by taking the molarity times liters, so 5.6 moles over liters, which is what molarity is, times the number of liters. So I'm going to convert that to liters, divide by 1,000, 0.5500 liters. Okay, so liters cancel, and our answer will be in moles, and with two significant figures, it would be 3.1 moles of H2SO4. Okay, now that we know the number of moles of that, we can just do stoichiometry to determine the moles of the aluminum hydroxide. So 3.1 moles of H2SO4. And there are 2 aluminum hydroxides for each 3 H2SO4. Okay, so the H2SO4s cancel. 3.1 times 2 divided by 3 will give us 2.1 moles of aluminum hydroxide. So we're almost there, because the question asks us how many grams of aluminum hydroxide would need to be added to the solution to neutralize it. So hang on to this number of moles, and we just need to convert that to grams. Okay, so I'm going to put that up here. So we have 2.1 moles of aluminum hydroxide. And we want to convert that to grams. So how many grams is in a mole? So we have 1 aluminum, which is 26.98. We have 3 oxygens, so that'd be 3 times 16. And we have 3 hydrogens, so that will be 3 times 1.01. So all of that adds together, you're going to get 78.01 grams in 1 mole. Okay, so I'm just going to put that up here. 78.01 grams per mole. Moles cancel. So 2.1 times 78.01 will give you 163.821 grams. However, we can have just 2 significant figures, so that would become 160 grams of aluminum hydroxide. Okay, so again, if given the concentration and the volume of this, if we add 160 grams of the aluminum hydroxide, it will produce a neutral solution that will neutralize this acid. Okay, that's it for the questions in the additional practice problems for Chapter 11.